Had some short discussions about reference angles already in class. People have referred to them in some of our brainstorms, or we've kind of like talked about them in addition to our coterminal angles. So we're just going to kind of clarify on the very first slide what we mean by reference angles, and then we'll look at some examples of problems you're going to see on your homework. So a reference angle is defined as an acute angle. And I'm actually going to add an adjective in there. I'm going to say it's a positive acute angle. You might recognize that notation for the reference angle, theta prime. And this acute angle is formed by the terminal side of your angle. So remember when we learned standard position on day one, I said it's really important you know where the terminal side is. The terminal side of your angle and the horizontal x-axis. Now, for the horizontal x-axis, it could be the positive x-axis or it could be the negative x-axis. It's going to depend on whichever part of that x-axis gives you an acute angle. So you want to go back to that piece that makes it acute. You use reference angles generally for angles that are greater than 90. So those are going to be the angles that appear in quadrants 2, 3, and 4. Now, what's really great about the unit circle is the unit circle does most of the reference angle work for us. So back in Algebra 2, you would have to sketch the angle, determine the reference angle, draw the right triangle, do SOHCAHTOA, do all students take calculus, and then have an answer. Okay? Now, what we really need to do is have an angle on the unit circle, know the angle's coordinates on the unit circle, and do sine, cosine, or tangent, okay, from our definition. So it'll be a little bit easier than it was in Algebra 2. Just to put a visual as well to what the reference angle is, so if you want to draw an example of what a reference angle is, draw an x and a y coordinate plane. And then we only have it for quadrant 2, 3, or 4, so this is an example of quadrant 2. Draw an angle in standard position, so you would have an initial side on the positive x-axis. You would place your terminal side somewhere in quadrant 2. And then that red arc represents your original angle. It's now more than 90 degrees. To find its reference angle, remember in the definition, it's the acute angle formed by the terminal side and the x-axis. So I'd have to go to the negative x-axis, and that gives me an acute angle. Yes, in quadrant 2. Very good. Now, I also have images for quadrant 3 and quadrant 4. So if you want to draw the images for quadrant 3 and quadrant 4 in your notebook, you're welcome to do so. Notice that we're always, when we're drawing, the book has it in blue, but I'm going to highlight it in green. We're always going from the terminal side, somewhere in quadrant 3, to the x-axis so that it's acute. So that's going to be back to the negative x-axis for quadrant 3. Okay, and there's my reference angle. In quadrant 4, I go from my terminal side now to the positive x-axis so that my reference angle will be acute. So what I want you to do is have a conversation and jot some things down in your notebook for quadrant 2, quadrant 3, quadrant 4. How can you find the reference angle if you already know the value of the angle theta? Okay. So imagine, like, if there was an angle in quadrant 3, and if you need to with your group maybe say, okay, 240 is in quadrant 3, how do I find its reference angle? And you should have 2 answers for each quadrant, 1 in degrees and 1 in radians. So think about how do you calculate the reference angle if you know the angle? Have it in there.
want to, what you do is you do 180 or and it's in the reverse here for negative or you're finding the reference. So right here, that's pretty cool.
Yeah. You guys understanding the text here? Yeah. So we can take data. Okay, so what could you write? Data times equals what? 180 minus 8. Do that for each quadrant. But I know how to do that. Like if I was doing the problem, like you need say that. Yeah. Sure.
Huh? I did 270 minus 8.
So, what is that?
What does it mean? How do you know that?
Because 4 pi over 2 would be 2 pi, which is 3.
Now we'll go back to that. You want to go back to that?
It's gonna start raining.
Okay, great. I'm seeing some really good stuff as I move around the room. Some of us are obviously pros at reference angles.
Really?
No. So in quadrant 2, essentially, if you think back to geometry, you have two angles, theta and theta prime, that are like a linear pair, right? So you want them to add up to 180. And so you just have to think about, if I know what theta is, what's left to get to 180? Do 180 minus theta. And if you're in radians, you don't need to convert it into degrees. You just do pi minus theta. Okay, so that works out for quadrant 2. In quadrant 3, essentially you have an overflow, something beyond 180. So how far did I go past 180? Just take your angle and subtract 180. So theta minus 180 or theta minus pi. And then in quadrant 4, instead of having two things that add up to 180, you need two angles that add up to 360. So theta prime is going to equal 360 minus theta, or 2 pi minus theta. Now, I don't necessarily memorize all of those, but I do have an understanding of why that is in the specific quadrants that I'm looking at. And so that's why I wanted you to kind of have those discussions with your group members. If you forget, if you don't remember these rules, you can still problem solve and come up with, okay, if it was in the third quadrant, I would subtract pi, and that will work out. Now, there is one side note here. Theta must be between 0 and 360 or 0 and 2 pi. So remember, I kind of had that conversation, like if you're doing a unit circle trig ratio, theta has to be between 0 and 360 or 0 and 2 pi. So we're going to use oftentimes a lot of co-terminal angles to get us in that range, 0 to 360, 0 to 2 pi. So if you have negative angles, if you have angles that are greater than 360 or greater than 2 pi, use a coterminal angle first before we find the reference angle. Okay, so next up are just some examples of things that you're going to see on the homework assignment. So first example, I'll give it to you and I'll give you some time to work it out. There is essentially two things that you're doing. Could you please sketch theta in standard position? So that's going back to day 1. Number 2, find its reference angle. Okay, that's today.
So you draw me French angle, and then I realized that this is a social but when you sketch it, you will use the other people for the reference.
Okay, going back to day one, if I want to draw an angle in standard position, draw an XY coordinate plane, draw my initial side on my positive x-axis, figure out where my terminal side should be. Because this is negative 225, I'm going clockwise, so this is negative 90 degrees, negative 180, and then negative 270. So I know that it should be somewhere in between negative 80 and negative 270. Some people, if you're familiar with your unit circle, you might be able to say, oh, negative 225, that's going to be the 135 angle in quadrant 2. So then you don't have to label or think about the size. Totally acceptable. You should also show for me the direction in which your angle opens. You're sketching the angle theta, and theta is negative 225, so you should be showing the arc going clockwise, 225 degrees. Now, when you're finding the reference angle, we want to do a reference angle for an angle in quadrant 2, so we want to do 180 minus theta, but it's important that theta is between 0 and 360. You know, if you thought about 180 minus 220, negative 225, that's going to be something really big. So I need to come up with a coterminal angle for negative 225. Coterminal angle, if you don't know it, just do negative 225 plus 360 is 135. Again, if you're familiar with the unit circle, you might already know that the coterminal angle is going to be the 135, because that's the angle that you actually graphed over here, right? So 180 minus 135, and our reference angle is 45 degrees. Nice work. So you'll have some problems like that. Remember, graph the original angle, do what you need to do to the angle if you need to find a coterminal angle so you can find the reference angle. Turner.
So why is it not negative 4?
Reference angles are positive.
When you draw the angle, can you just draw the
If I'm asking you to sketch theta equals negative 225, negative would imply that your angle were going clockwise. So while you might be thinking about, oh, it's the 135 angle in quadrant 2, your sketch should still represent that you're graphing the negative angle. Just like if you were graphing like negative 450, you would show that extra rotation, even though it's the same thing as negative 90. Okay, another type of question that is going to be on your homework, and this we've already had some practice with, it was similar to our warm-up yesterday, are evaluating trig ratios. At this point, you're not even really using reference angles, right? The reference angles are in the unit circle already, because we took those little triangles and flipped them around and did all our stuff. So now we're really focused on our unit circle. So maybe talk with your groups if you want. See if you guys could come up with answers for secant of negative 480 and cotangent of negative 13 pi over 6. How about you go here for you?
I added 360, so that would be negative 120, and 120 is 2/3 of 180, and over 3 is when you use 30.
I know what you're saying.
How about you? So you're getting, oh no. Alright, so it's 240. Oh, 4 pi over 30.
You see what I'm saying? Okay. No, so what I was saying is how I think of it is 120. That's like a third in thirds. And so 60 is a third, so you know that you're looking at 60 degrees.
Oh,
You see what I'm saying?
yeah, like it's 180.
Like if it's over 4, you know that's 45. There's like 45 and a fourth of 180, so you're looking at whatever, 45.
I like to do 480. But you can use a calculator. You can do that math in your head.
Yeah, I think it would be the same thing. So secant would be over x. The cosine of 60 degrees is 1.
Okay, we'll come together and kind of see how we're doing so far. Like I said, you did some of these yesterday in your warm-up, so nothing really has changed here. Negative 480 plus 360. You want to find the coterminal because negative 480 isn't anywhere on the unit circle, right? That's not a helpful number. So that comes out to negative 120. So that's also not on the unit circle. I would add another 360, and we're really looking at the angle 240. Now, 240 on the unit circle, that's in quadrant 3. I know its coordinates are negative 1/2, negative square root 3 over 2. You're responsible for knowing that unit circle, so you should be studying that. And then I want to answer the secant of negative 480. Its coterminal angle is 240, so it's really the secant of 240. Which one of these coordinates am I going to use for secant? The x, because it's the reciprocal to cosine, and cosine is x. So then I would do the reciprocal of negative 1/2, which is negative 2. Okay.
So like what does negative 2 represent? What is it?
It's the ratio of the hypotenuse to the adjacent.
Are those opposite degree or?
No, it's a ratio. The hypotenuse is twice the adjacent side, and it's negative because you're going left and down. Or sorry, you're going left, and the hypotenuse is the radius, so it's positive.
Got
For cotangent negative 13 pi over 6, I would do the same thing. Do my coterminal work, so I'm going to add 2 pi, which is really 12 pi over 6. That gives me negative pi over 6. So I'm just going to add a 12 pi over 6 again. That gets me to 11 pi over 6. I want mine to be between 0 and 2 pi because then that's an angle on the unit circle. So negative 11 pi over 6 is positive square root 3 over 2 and negative 1/2. Oh, and the tangent of 11 pi over 6 is negative, because it's in quadrant 4. And what's the tangent of pi over 6? Radical 3 over 3. So for cotangent, I just need to do the reciprocal of that, which will be negative square root 3. So square root 3 and square root 3 over 3 are reciprocals of each other. Any questions about that? I mean, what you're finding on those examples and when you're doing them on your homework assignment is we're not really even using the reference angles at this point, right? In Algebra 2, you would have used the reference angle to figure out which triangle you're working with, but we already did that when we crafted the unit circle. So we've already kind of taken care of all the reference angle work. Is there a question there? Bailey?
If we are using the reference angle to figure out which triangle we're working with, that hurt us in the future if we can.
It's just a time thing.
So it's like it won't.
You should get the same answers. Yes?
I'm just why you're adding 12 pi over
It's 2 pi. 12 divided by 6 is 2.
6. Okay.
And I need common denominators for 13 pi over 6.
Why did you add it twice?
Because if I add it once, I'm at negative pi over 6. And if you can recognize that negative pi over 6 is 11 pi over 6 on the unit circle, like you're going clockwise, and you can name that coordinate, that's fine. But I always like to make sure my angles are between 0 and 2 pi. So negative pi over 6 is less than 0. so I added it again. They're coterminal angles. Again, my whole goal is to find it so it's equal to one of the angle measures on the unit circle, and then I can pick out that coordinate. Okay, good question. Fine. Coterminal of what? Yes. So the tangent of 11 pi over 6 is negative square root 3 over 3. So if you do the reciprocal, it is negative square root 3. Anything else? Okay, the last questions that are similar to what you're going to see on your homework tomorrow are finding solutions of an equation. So just so that you're kind of familiar with this set of directions. It says find two solutions to the equation, but two solutions really means 4. Because you're going to give your answers in degrees, so there are 2 angles in degrees, and then there are 2 angles in radians. So you're really writing 4 angles down, but there's 2 answers. So talk with your groups. And you should be able to do this without a calculator. What's theta if sine of theta is negative square root 2 over 2?
Sine is negative in quadrant 3 and 4. No. So the angle in degrees would have to be 225 and 315. Those would be the angles. Well, you know, the sine of y equals square root of 2 over 2, 45. So then, but you know, it's negative. So in the first quadrant, all of them are positive, so it should be positive 45. In the second quadrant, it would be 135, but that's also positive, it's even. So it has to be 3 and 4, but it's sine is negative. So then 180 plus 45 is 225, and then 360 minus 45 is 223. So those are 223 measurements, and the radian is
4 and 7 pi over 4.
You can do the others. If you get sine of theta equals negative square root 2 over 2,
yes.
talk about the others.
I just like look at the degree. I'm trying to figure out the radian part in my head.
Okay. So, if you just find negative radical over 2, well, you know that the formula when you said that's when you 45 degrees. So the 3 quadrant one. So then from there, you know that.
Oh no, I was on the first part. They're not coterminal.
Right?
I just.
So it can't be quadrant 1. It can't be quadrant 2.
Oh no.
And all 3 are getting out.
This was the
Your
beginning.
sign is going to be positive. That means if you do quadrant 3, and then if you do
Just 5 and 75.
Well, the radian, you know, it's a 45, so like, well, I think that is, you already know that's the third and fourth, so then you have 4 pi over 4 is 25, so add 1/4 of that, so add a fourth, so pi over 4, so pi over 4 plus 4 pi over 4.
As far as
And the next one you go, another pi over 4 is halfway, and then another,
like 225.
Does that make sense? Okay, so this is the degree one.
I don't know what.
Well, because you know that.
Oh, you used both words.
Yeah, because sine is negative in 2 different places.
Okay,
So you can't
okay.
share which one it is.
And then you just need to deal with the oh, okay.
Yeah, I'm not going to memorize the overall.
Okay, so what I do is in the middle, 45, you already know that that's radical 2 over 2, you radical 2 over 2, but those are the same.
Yeah.
40. That's the easy one. And then for this one, I remember that 30 degrees is the first one to come up, so the first number you're going to write is going to be 3. So that's why you know you already read the 3 over 2.
3, 2, 1, 3, 2, 1. 3, 2, 1. 3, 2, 1.
That's what it's doing. And then I know that I know the 3 over 2, and that is the other one to be 1 half. And then this one is the opposite. So,
No.
And then again with the 3 thing, I know that this is radical 3 over 3 because the 3 is the person right here, so 3 is going to go. But for this one, I defer that's radical 3. So there you go.
Then once it starts going around.
Once it starts going around, it's a little bit trickier, but
Yeah, I think I might have to write it out.
like I said, you can write the first plot right here.
Okay, I'm going to interrupt. You may or may not have all of them done. That's okay. I'm going to talk about sine theta equals negative 2 or negative square root 2 over 2. I heard some really good conversations going around the room from different groups. So I heard a lot of people say, okay, it's the sine of theta, so this thing is the y. And y is negative in the quadrants 3 and 4. So what angles have sine of, or a y coordinate negative square root 2 over 2 in quadrant 3 and quadrant 4? I think about them, actually I get better with my radians. I know in radians in the first quadrant it's pi over 4, right? So then I just have to know my pi over 4s in quadrant 3 and quadrant 4. That is 5 pi over 4, which is 225 degrees. And also 7 pi over 4, which is 315 degrees. So on your homework tonight, write out both sets. Write out the radian angles, write out the degree angles. This will help some of us who are having trouble with the angles on the unit circle. Okay. If you're thinking about tangent of theta, and tangent of theta is undefined, remember, when you evaluate tangent, it's whatever y divided by x is. What do you know about one of your coordinates if it's undefined?
It's divided by 0.
It must be divided by 0, so x is equal to 0. So it has to be 0, comma, something. What are the 2 angles that have zeros for x's? 270 and 90. So 3 pi over 2 and also pi over 2. Alright. For the other 2, cotangent and secant, you know what I would do is like change them into their reciprocals, because then I'm better at knowing those things on the unit circle. So the reciprocal of this cotangent would just be the negative square root of 3. And then again, I saw a lot of people using like that all students take calculus. In which 2 quadrants would tangent be negative? Quadrant 2 and quadrant 4. The angle that has a square root 3 tangent in quadrant 1 is your 60 degree angle. So in quadrant 2, you could just do your reference angle. 180 minus 60 is 120. So it's going to be 120 and in quadrant 4, 300.
Good morning, this is Mr. Fields, principal for St. Louis South. This is just a reminder as we go into this period that 9th grade students, current 9th grade students, during their time, they need to report to time first, get the attendance taken, and then they will be dismissed to the theater for a presentation regarding registration. So again, 9th graders report to time first, and they will be dismissed to the theater. Thank you. Everyone.
Okay, and I put up my other answers if you want to check yours, that's fine. So do that homework.